All right, so we're going to be taking a look at a concept that comes up in our Desmos activity for today. It's about a new way that we can describe patterns. So we talked earlier about describing patterns as increasing and decreasing, but we're going to talk about a different way to describe them today, which is thinking about them as either linear or non-linear. So go ahead and title your page. I put mine CMP, Patterns and Variables 2.2. And we're talking about linear and nonlinear patterns, and I put my name in the top right as well. So we're going to talk about a new way to describe patterns, right? And I want first for us to focus on these two pictures here, right? And to think about what differences we see. So you might make some noticings about these two graphs, right? That boil down to things like this one makes a straight line, and this one doesn't make a straight line. You might also notice that in this one, it goes up by the same each time, where this one it doesn't, right? Because sometimes it goes up, sometimes it goes down. So we could say changes. So maybe I could say that the pattern stays the same the whole time. Right? Because in this graph on the left, we have one pattern, it goes up like this, and it always goes that same way. On the right here, that's not true, right? If I take my, if I'm looking for a pattern, here it's going up like this, but over here it's going down, and even here it's going up, but not by the same amount, right? So I'm going to say that this one, the pattern isn't always the same. Okay, so I want to talk about some labels that we can put on these two types of patterns. So if a pattern stays the same throughout a graph like this, we can call that pattern linear. We're going to come back in a minute to this, but the reason why we call it linear, right, it has line right in the name, right? The reason why I call it linear is because often these points should make a straight line, right? So we say linear because it makes a straight line, right? You can connect linear to line. That would mean that this pattern over here that doesn't make a straight line is what we call non-linear. So if a pattern is non-linear, it doesn't make a straight line, and the pattern doesn't always stay the same. So this, from the graph, you can see maybe an easy test that emerges, which is if I want to see from the graph if it's linear or non-linear, I just have to see if it's a line or not, right? To be really clear, linear patterns can look like any kind of line, right? I'm going to draw some other linear patterns on this graph over here. This would be linear, right? This would be linear. This would be linear, right? It's a different kind of line, but it's still a straight line. Or this is linear, right? All of those are linear. Non-linear, I mean, you could come up with a million examples, right? This isn't linear. This isn't linear. This isn't linear. All kinds of things. I want to give you one example, too, of a non-linear one that you might see. This, for example, not linear, right? Yes, each of these ports is straight, but the pattern doesn't always stay the same, right? So we would call that non-linear. So I want to talk about one more thing about linear versus non-linear, which is how we can see these two types of patterns in a table as well, right? So I'm going to drag this table down here. So I want to look at one pattern that's linear and one pattern that's not linear, right? So remember that it's really important to remember that the pattern stays the same for a linear pattern, and the pattern doesn't always stay the same for a nonlinear pattern. So if I'm looking at a table, I can tell if something is linear or nonlinear by looking at the pattern I see between the numbers. So for example, if I wanted to look at tour price and number of customers, I'm going to make a noticing about the pattern I see, and I'm actually going to steal my noticing from one of your classmates who said that every time the price goes up by 50, the number of customers goes down by 5. And let's see if that pattern stays the same. Well, yep, I'm keep adding 50 to go from $150 to $250, and I subtract off 5 customers. And I can go this whole way, and that pattern stays the same. I'm always adding $50, and I'm always subtracting 5 customers. So since this pattern stays the same, we would say this is a linear pattern. Okay, I want to look at a slightly different example. Let's look at tour price and tour income, right? So we know that tour price is going up by 50 each time, right? Let's look at the change we see in tour income. Is it always going up by the same pattern or not? Let's see. So when the tour price is $100, the tour income is $4,000. And then when we increase the price by $50, our income goes up by $1,250. When we increase the price by 50 again to get to 200, right? We increase again. Our price goes up by $750. When we increase our price by 50 again, our income goes up by only $250. When we increase our price again by 50, our tour income actually goes down by $250, right? And we can go on and on and on. But one thing you'll notice, right, is that this pattern doesn't stay the same, right? It's not going up by the same amount each time. And that tells us that this is a nonlinear pattern. So we now have a bunch of different ways that we can describe patterns. We can say they're increasing or decreasing. We can say they're linear or nonlinear. These are really helpful ways to tell to describe patterns, to be able to describe them to classmates, and, but also to write about them, right? So like if, for example, if we saw this in a problem when we graphed our data, and we're asked to write what we notice about the pattern, we can now say, we don't have to just say it goes up and down, we can say it's nonlinear, right? The pattern isn't always the same. All right, so we're gonna get some more practice with this next week, but I hope this was a good overview for you and it helps you with your Desmos activity for today.